This week we're focusing on air pollution, specifically three kinds: CFCs, acid rain, and excess greenhouse gases. CFCs were synthetic molecules that were used in aerosol cans and coolant. CFC molecules interacted with ozone molecules in the atmosphere and broke those down. This broke down the ozone layer, or the layer of the atmosphere that protects us from harmful radiation. This problem was, in a way, relatively easy to fix. The government simply just banned the use of CFCs. There were other ways to make aerosol cans and cooling systems work, and so CFCs were substituted for these other options, and the ban on CFCs has helped the ozone layer to slowly replenish itself with each passing decade. Acid rain was a problem that occurred when the byproducts of combusting fossil fuels mixed with precipitation, forming acidic rain. Acid rain was addressed in the 1990 Clean Air Act amendments in the United States. This legislation mandated that automobiles be fitted with catalytic converters and power plant smokestacks be fitted with scrubbers to remove some of the substance from combusting fossil fuels that helped cause acid rain. This legislation also mandated the use of permits and caps on the production of forms of pollution that led to acid rain. Problems associated with acid rain and CFCs are far less prevalent today because of the actions that were taken in past decades. The primary problem relating to atmospheric pollution that we face today are excess levels of greenhouse gases. Greenhouse gases like carbon dioxide and methane are gases that can interact with heat energy and slow the loss of heat from the surface of the Earth into space. Greenhouse gases are called this because their action is similar to that of a greenhouse. The way a greenhouse works is that the panels of a greenhouse allow light to enter it. When that light is translated into heat energy, it slows the loss of that heat energy. This allows the greenhouse to warm up. Similarly, in our atmosphere we have greenhouse gases. These gases allow the light of the sun to pass through and reach the surface of the Earth. When that light energy is transformed into heat energy, greenhouse gases slow the loss of that heat from the surface of the Earth into space. The greater the levels of greenhouse gases, the more that heat builds up on the surface of the Earth, and the warmer the temperatures get on average. In order for a molecule to be a greenhouse gas, it has to have two separate properties. One, that molecule has to be made of 3 or more atoms, and 2, that molecule has to be made of 2 or more elements. So for example, a molecule of carbon dioxide has 2 elements, carbon and oxygen. This molecule also has 3 atoms, 2 oxygens and 1 carbon. As a result, a molecule of carbon dioxide can interact with heat energy, which is actually called infrared radiation. On the other hand, molecules like oxygen or nitrogen gas only have 2 atoms in each molecule, and they only have 1 kind of element, oxygen or nitrogen. As a result, these molecules cannot interact with infrared radiation and do not slow the loss of heat from the surface of the Earth into space. Combustion, cellular respiration, and decomposition add carbon dioxide to the atmosphere. Photosynthesis removes it. The reason we're seeing CO2 levels rise is because the rates of cellular respiration, decomposition, and burning are occurring at a faster rate than rates of photosynthesis. As levels of greenhouse gases like carbon dioxide increase in the atmosphere, they start to change climate patterns. More CO2 in the atmosphere means a warmer atmosphere, and a warmer atmosphere has more energy to hold on to precipitation. Under moderate levels of carbon dioxide, we tend to see more frequent and more moderate levels of rainfall. In atmospheres with high levels of CO2, the atmosphere can hold on to that precipitation for longer periods of time. This means that there are both more amounts of time between episodes of precipitation and more precipitation during each event. This increases the rate of both droughts and flooding in environments. This not only interferes with ecosystem function, but also reduces our capacity for some forms of human activity, particularly agriculture. Agriculture usually depends on moderate, frequent amounts of rainfall. When we have large amounts of time between episodes of rainfall and a higher likelihood of flooding during those rainfall events, agriculture is more at risk and crop yields tend to decrease. In order for us to produce a sufficient amount of food, we depend on a stable climate. The higher the amount of carbon dioxide and other greenhouse gases in the atmosphere, the less stable the climate, and the lower our capacity to produce food on a global basis.